Solve for on, let's build the future. One line of code, one dream at a time. From the cloud to the console, the rhythm flows. Innovation lives where the knowledge grows.
Hello and welcome to this lecture on persistent volumes in Kubernetes. I'm EsthyTech. But before we head into persistent volumes in Kubernetes, let us look at volumes in Docker first. Ever wonder why your data disappears the moment a container or pod dies in Kubernetes? That's where volumes and persistent volumes come in. The secret to making your data stick around in Kubernetes. Let's break it down. Containers are ephemeral. They are short-lived by design. In Docker, when the container dies, the data inside it dies too. To solve this, Docker lets us attach volumes. That way, even if the container goes away, the data survives. As illustrated below, Kubernetes pods are no different. They're also transient. If a pod goes down, any data inside goes with it. But by attaching a volume to a pod, we can persist that data. Even after the pod is gone, the data stays safe in the volume. Let's say we create a pod that generates a random number and writes it to a file. If the pod is deleted, boom, the number's gone. But if we attach a volume backed by the host's data directory, that file now lives outside the pod. Pod gone, no problem, file still there. To use a volume, we mount it into the container's file system. For example, mounting /data on the host to /opt in the container. Now the app thinks it's writing inside the container, but it's really writing to persistent storage on the host. Storage options. Host path works for a single node cluster, but in multi-node clusters, it's unreliable. Pods may get rescheduled on another node that doesn't share the same data directory. That's why Kubernetes supports many other storage backends: NFS, CephFS, GlusterFS, iSOCI cloud storage like AWS EBS, Azure Disk, Google Persistent Disk. For example, instead of host path, you could configure an AWS EBS volume by specifying its ID and file system type in your YAML. Why persistent volumes? Sneak peek. Now here's the challenge. Manually attaching volumes to pods is fine for small setups, but in production, you want a cleaner, more scalable way to manage storage. That's why Kubernetes introduces persistent volumes, or PVs, okay, and PersistentVolumeClaims, or PVC, a way to decouple storage from pods, making it easier to manage at scale. We'll dive deep into that in the next lecture. And that's your crash course on volumes in Kubernetes. Next up, persistent volumes, where things get really powerful. If this helped you, smash that like button, drop a comment with your Kubernetes questions, and don't forget to subscribe for more cloud native deep dives. See you next time.
Solve for on, let's build the future. One line of code.
Hello and welcome to this lecture on persistent volume in Kubernetes. In the previous lecture, we learned about volume. Now, we will try to create a persistent volume and a persistent volume claims. Still mounting storage inside every pod YAML. In real clusters, that's chaos. Kubernetes has a cleaner way. Persistent volumes and persistent volume claims. Centralized storage your apps can claim on demand. Let's make your data actually persistent. When we define volumes directly in a pod, every team has to repeat storage configs in every manifest. If the storage changes, you edit all the pods, not scalable. Enter persistent volumes, PVs, storage objects provisioned by admins at the cluster level. Developers request storage using persistent volume claims, PVCs. Kubernetes auto-binds the right PV to the PVC based on capacity, access mode, storage class, and more. Binding rules. One PVC binds to one PV. K8 looks for enough capacity and matching access modes like read-write once, read-only many, or read-write many, plus volume mode, file system versus block, storage class name, and optional selectors. If a perfect fit isn't available, the claim stays pending until a PV appears. A smaller claim can bind to a larger PV if it otherwise matches. What happens when a PVC is deleted? The PV's reclaim policy decides retain, default, keep the volume for manual cleanup, delete the external volume, recycle, legacy/deprecated, scrub and reuse, rarely used today. Dynamic provisioning. Manually creating PVs is fine for demos. In production, use StorageClass for dynamic provisioning. The PVC triggers the cloud driver, CSI, to create storage just in time. Think AWS EBS GP3, Azure Disk, etc. That's PVs and PVCs. The clean split between cluster managed storage and developer requests. Stay tuned for the step-by-step lab. If this saved you config headaches, like, comment what backend you use, and subscribe for more Kubernetes in plain English.
EsthyTech, your tech journey starts here. Coded dream.